Okay. So, any questions on that? Chastity, any questions? Alright. So, that's good. Alright. And then and we also talked about t-distribution. Okay. So now let's get ahead to the next thing for real. Let's do all of this, but let's do it for proportions. So find a 95% confidence interval for P, the proportion, when you take a survey and get P hat is 0.62 and N is 350. So what's the first thing that you should do here? Well, with confidence intervals, the first thing I like to do is I like to write down the formula. So for a confidence interval, what's going to be the formula? Well, the formula was, let's see, the formula was x bar plus or minus z times sigma x bar. But now we're dealing with proportions. So for proportions, update it. What do you think the confidence interval formula is going to be? Z times sigma for P hat. That's it. Now in this problem, do we know P hat? What is it? It's 0.62. So plus or minus, do we know Z? No, so we're going to need to figure that out. Do we know sigma P hat? No, but we can figure that out. Okay. So those are the things that we're going to need to figure out. Now, back to the problem as it goes. What's the next thing that we should calculate or figure out in this problem? Let's find sigma P hat. Okay. So what is sigma P hat? There's a square root involved, yes. Exactly. What's the formula for sigma P hat? It's the square root of I'm gonna write out the formula just to remind people. It's P times 1 minus P divided by N. Exactly. So remember, that's the whole thing, is that the formulas are more or less the same when you're dealing with either means or proportions. The confidence interval formula looks the same, but the main difference is the formula for the standard deviation. And that's an important distinction to remember. Okay. So here's another detail. What is so if we were to fill in numbers in this problem, what would be the square root of what? 0.62 over 350. Okay. Now we're going to go ahead and calculate that. I just want to point something out. The formula, as we've learned it and used it, was using P. Now notice that for a confidence interval, we don't have P. But what do we have? P hat. So that's what we have to use. So we just sort of make the slight adjustment that we're not really using P's here, we're using P hat. But that's okay. Alright, so now we have to go ahead and calculate this. 0.62 times 1 minus 0.38 divided by 350. 0.0259. So there's sigma p hat. Great. We needed that. Now we can fill it in. Now what's the next thing we should do? Yes, but before we draw the picture, what do we need to say? Is it normal? Exactly. So how do you check if it's normal? Nope. It's NP1 minus P is greater than or equal to 10. Right. And again, we don't have P, we just use P hat, it's okay, don't worry about it. Alright. So N is 350, 0.62, 1 minus 0.62. Is that at least 10? You work it out and you get 82 something or other, which is certainly greater than 10, so you're good. And now that you know it's normal, what do? Draw the picture. So here's the picture. Now what do we label on the picture? Yes. So the key thing, 95% confidence interval means you have 0.95 area in the middle. So once you do that, what else can you label? Oh, okay, yeah. So you can also say I've got Z's and I got P hats here. Okay. So for Z, what goes in the middle? 0. And for P hat, what goes in the middle? 0.62. Okay. So that's all the given information. Now we need to start figuring things out. So now what can we figure out? Right. So how much is in each tail? 0.05 in both tails, therefore each tail is 0.025. And then once you know that, what can you do? Now we can find the z-score. Okay. So we did this once using Excel, so let's try doing StatDisk. So in StatDisk, you pull up the normal distribution, and what do you type in? Area to the left, which is 0.025. And once we round that, you get 1.96. And that's what we needed. We needed the z-score. So there you go. The z-score is 1.96. Now our formula is filled in, and then now the rest is arithmetic. So 1.96 times 0.0259, that's 0.0508. And then if you work that out, you get 0.5692 and then 0.6708. And that is the 95% confidence interval for P. Okay. Any questions about how to work through this? Is that straight? Okay. Now a little comment about proportions. when we talk about a proportion of the population, do we usually say, if you're just talking to someone, would you say, oh, 0.62 of the population said yes? Typically, what would you say? Typically, you would say 62%. So a lot of times what we'll do is when we state this as a conclusion, you can convert it to common language. So one way to express this in common language is to say that it's between, instead of, or say P is between 56.92% and 67.08%. Now, of course, even more so, very rarely say 67.08%. Typically, we would probably just say 67%. So again, continuing with our common language rounding and approximations, we'd be much more likely to say is between 57% and 67%. And similarly, we would say in our sample, we got 62% plus or minus, instead of saying 0.0508, that's a percent too. It's 62% plus or minus 5%. So with proportions, we would, again, when stating conclusions in common language, we would typically not say it in terms of decimals, we would typically say it in terms of percent. But this is actually really important. This is important because this is actually how results of polls and such get reported in the news. When someone takes a poll, they'll say, we did a poll and 62% of Americans support such and such. Whatever the current issue is. Civil unions for gay people is a current topic right now. Okay. So what they will tell you is 62% said yes. What they won't tell you is everything else that we just did in a typical news report. Why? Because most people don't know statistics. But now you guys are now smarter than the average bear, so you know this stuff now. So what they are telling you is the p-hat is 0.62. What are they not telling you? They're not telling you their confidence level. They're not telling you their margin of error. They're not telling you how many people they surveyed. Not telling you unless you go find the poll and go read the fine print. And that's something that we're actually going to talk about a little bit today as well. So for example, I want this one. Here we go. So I just went and I just pulled up some poll. Recent poll. New York Times, CBS News poll. Americans have grown more optimistic about the economy and the direction of the country in the 11 weeks since President Obama was inaugurated. Blah, 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 according to the latest New York Times CBS News poll. This is how the survey results would probably get interpreted in the news, or if there was just going to be one blurb. But we now know there's much more that goes into it than just this. So, first I'm going to show you some of the numbers. So if you click on original document, you actually pull up you see everything that they did. So a pollster will do what? They'll ask the question, do you approve or disapprove of the way Barack Obama is handling his job as president? And they've done something very interesting here. They're actually tracking the results to this question over time. So you see, for example, over here, the results are from February 2nd to 4th of 2009. And then they have later in February, then March, later in March, and then April 1st to 5th, 2009. So you can actually track Obama's approval numbers. Approve, disapprove, and DKNA is standard pollster speak for don't know or no answer. Now, of course, this is a serious poll from a serious organization. They did a lot of work. Do you feel things in this country are generally going in the right direction? Do you think, or et cetera, et cetera? And they have the results all the way back to 1991, done periodically up through April 2009. Do you approve or disapprove of the way Barack Obama is handling foreign policy, handling the economy? And again, there's page after page after page of all this polling data. So again, professional pollsters, this is what they do. They collect all this data. So this is some of... So again, what you might see in the news is that Americans have grown more optimistic. But some of the numbers behind that would be, well, February 2 to 4, the approval rating was 62%, then it was 63%, then 62%, then 64%, and now his approval rating is 66%. And that's one way to look at this. But there's more. Sorry, question? Okay. So another aspect of this to discuss is something we were just talking about earlier. What happens when you... So this was a conclusion in the previous problem that we reached. We did a 95% confidence interval. What happens if you say that you want more confidence? What happens if you increase your level of confidence? Sorry? What's lower? What happens to the margin of error? The error gets smaller. So you're saying we have higher confidence and smaller error. Let's take a look. Where's my little picture? Oop, I lost my picture.
I think that the error would get.
But where's the error? So this is the thing. So this goes back to the picture that we had before. Okay. So in this picture, so in these two pictures side by side, what we have over here, the first picture is the picture for 95% confidence. In the next picture, let's say we have here, is 99% confidence. So what else has changed? The z-score has changed. How did the z-score change? The 95% has a smaller z-score. Exactly. So smaller confidence gives you a smaller z-score. So when your z-score is smaller, what does that do to your margin of error? Sorry? Well, look at the picture.
It makes it smaller.
Yeah. Where's your margin of error? Your margin of error is here. That's a margin, because remember, because how do you get your upper bound and lower bound? You add or subtract your margin of error. So if you look at the bottom picture, here's your middle number, and the way that you get the bottom value is to subtract your margin of error, or the way you get your upper bound is to add the margin of error. So to go from here to here, that's a margin, that's E, that's your margin of error. So when the middle area gets bigger, what happens to your E? It's getting bigger. The distance between your middle value and your bound, your upper or lower bound, is getting bigger. So bigger confidence, bigger margin of error. And again, we already went through this discussion. We talked about it for means. It's exactly the same for proportions. The idea is the same with proportions. What's going to be different is the formula. That's what we're going to look at right now. So once again, suppose we say we want the margin of error to be a particular number. In this case, I'm going to say 0.03. And a certain level of confidence, say 95% confidence. And for now, I'm going to say take p hat to be 0.5, and I'm going to come back to that in a second. So what does n need to be? Well, we're going to go through the exact same way that we came up with the formula for n before. We're going to do that again, but the formula is going to be different. Because remember, sigma x bar and sigma p hat, those are different. So this formula is going to be different as well. So remember that in this case, margin of error is z times sigma p hat. But what is sigma p hat? What's the formula for that? Square root of p hat times 1 minus p hat over n. Okay. So remember, so the question, just as before, the question we're asking is what does n have to be? So we want an equation that says n equals. So we're going to have to go about solving for n. So to do that, that's algebra. So let's get to it. So what's the first thing we get rid of? Okay. So for about 30 seconds, and close your eyes. Okay. Okay, so good question. So being able to derive the formula, let's call that extra credit. Alright. So the first thing to get rid of is the z. So how do you get rid of the z? Well, right now, z is being multiplied, so what do you do to get rid of it? Divide. So that gives you this. Next, what's the next thing we have to get rid of? The radical. How do we get rid of that? Square both sides, which gives you this. So now we've got a fraction ends on the bottom of it, so I'm just going to cross multiply. So you cross multiply, that gives you this. And if we're trying to get n by itself, what do we get rid of now? The e squared. And how do you get rid of it? You divide. And that gives you your formula for n. Okay. So here's the formula for n, and again, notice that this is the formula for n when you're dealing with proportions and p hats and all that, because that gives you a different set of formulas. Now, let's try to apply that to the previous problem that we worked on. Now, n equals, okay, so let's fill in the easy stuff. What is E? 0.03, because I said so. That's what the question is asking. Yeah, that's good. Okay. So you got 0.03 squared. Now, what's z? We have to find it using what information? Right, and what's the area? You're told. What is the area? What area are you told? 95% confidence, exactly. So, right. So you're told that you have 95% confidence, 0.025 in each tail. So what's the z-score? 1.96. This is a mini question that we already answered. So we know our z-score is 1.96. Let's go back and fill that in. Okay. So the only thing left to fill in is what is p hat. Now, in the previous problem, or in the problem we just worked out, p hat was 0.62. So we could simply say, okay, p hat is 0.62, let me go use that. So you plug in 0.62 for p hat, and you get a certain answer. And sometimes that's a reasonable thing to do. The only problem is, what if you did another study and you got, oh, now my p hat is 0.58. So then you would plug in 0.58 and you would get a different answer for n. Maybe you did another study, you get 0.64, you plug that in and you get a different answer for n. But the question we're trying to answer is, how big a sample size do we need? Well, some people would object to saying, well, sometimes I need a sample size this big, sometimes I need it this big. So the question is, so one way to answer this question is, what sample size would cover every possibility? No matter what p hat is, what sample size n will cover everything? So in order to do that, you need to say, well, what p hat is going to give me my quote-unquote worst-case scenario? And it turns out, if you do some mathematical figuring, that value for p hat is 0.5. So p hat equals 0.5 gives you your worst-case scenario, gives you the value for n that covers all cases. So if you're told to consider in a problem like this, if you're told to consider the worst case scenario, make sure you use p hat as 0.5 and not the p hat that you're given. So in this case, we're going to do the worst case scenario. So p hat is 0.5 and then 1 minus 0.5. And when you work this out, you get 1068. So again, this is just from the formula, but using the worst case scenario value, p hat is 0.5. Now this problem is actually a really, really important problem. This reflects what actually goes on in the polling industry. In the polling industry, almost every professional poll follows the guidelines of 95% confidence and a margin of error of 3%. And 3% is the same as saying 0.03. So what does this mean? Almost every pollster needs 1,068 people to ask. So in effect, these are the professional standards of the industry. So again, what you can do is go find a newspaper, read the fine print, and read what their confidence is. Read what their margin of error is. Read how many people they actually interviewed for the survey. And that's what we're going to do right now with that New York Times poll about Obama. Let's check it out. So again, remember, the cover story was just the blurb. We've already seen lots of their data. But you notice what they also have is how the poll was conducted. Let's check that out. The latest New York Times CBS News poll is based on telephone interviews conducted April 1st through April 5th with 998 adults throughout the United States. And 998 is very close to what number? 1,068. Okay. So they met their professional requirement, give or take a little bit. Okay. Let's continue. The sample of landline exchanges called was randomly selected by a computer from a complete list of more than 69,000 active residential exchanges across the country. By the way, for anyone who doesn't know, the exchange, that's the first 3 digits in your phone number. Not the area, it goes the area code, then the exchange, and then the last 4 digits, which is just any number. Okay. The exchanges were chosen so as to ensure that each region of the country was represented in proportion to its population. Hey, what kind of sampling is that? Sorry? It's which kind of random sampling? There certainly is. Which kind of sampling? We talked about this. They took the population. The other one. They took the population. They broke the population down by exchange, which is the first digit of the phone number, and and by the way, you may or may not have realized this. Your neighbors usually have the same first 3 digits in their phone number. So exchanges are generally done geographically. So an exchange usually corresponds, say, roughly to a zip code, more or less. This is stratified sampling. Population was broken down by exchange, and then a random sample was taken from each exchange in proportion to how many people are there. Next, within each exchange, random digits were added to form a complete telephone number, thus permitting access to listed and unlisted numbers alike. What kind of sampling is that? Sorry? If they took the exchange and then just added on 4 random digits. Sorry? Convenience? No. What? That's simple random sampling. They're randomly generating numbers. That's a random sample. Simple random sample. Within each household, one adult was designated by a random procedure to be the respondent for the survey. To increase coverage, this landline sample was supplemented by respondents reached through random dialing of cell phone numbers. The 2 samples were then combined. What kind of sampling is that? So they've already called a bunch of landline phones. Now they're making sure that they're going to represent cell phones. What kind of sampling is that? That's experimental design, yeah. That's pairs going 1 by 1, and that's also experimental design. This is stratified sampling, because they've broken the population down into landline users and cell phone users, and they make sure they get some of each. Next, the combined results have been weighted to adjust for variation in the sample relating to geographic region, sex, race, Hispanic origin, marital status, age, and education. In addition, the landline respondents were weighted to take account of the household size and number of phone lines in the residence, while cell phone respondents were weighted according to whether they are reachable only by cell phone or by landline. So what is all this about? So they use the word weighted a bunch of times. So what they did with these numbers is they really took a weighted average. Now, why did they take a weighted average? Now, let me say ahead of time, some of this is getting into slightly advanced techniques that are certainly beyond the scope of this class, but important for professional pollsters. So why did they do this? Well, suppose they get a random sample. You saw they took all these measures to make sure they got a random sample. In their random sample, their sample is 55% 55% male and 45% female. Does that represent the population? Close, but not quite. The actual U.S. population, I'm not sure what it is. It's 50-50, or it might be 51-49 female to male. So if they get proportions, so again, just looking at gender, if they get proportions that don't quite match up, they say, well, we got 55% men, that's too much, so we need to weight those less. We got only 45% women in our sample, that's too little relative to the population, so we need to weight that a little bit more. And then all these other factors, they know, for example, ahead of time, well, we expect, or rather, what are the factors they use? Age, right. So if randomly they got, if half of their survey were people 55 and up, that certainly doesn't represent the population. So they take a weighted average of what their results were in order to make each demographic group count in proportion to the population. So again, these are advanced techniques that pollsters have to use, because doing these polls in the real world is messy. You don't get, let's flip back to the notes for a second. If you take a poll in the real world, you don't just get p hat equals 0.62 and n equals 350. That is a way oversimplified version of what's really going on. You get people don't know, no answer. You get people not responding. And so the thing is, how do you, as a professional pollster, try to adjust for these real world obstacles and problems that come up? So we talked a little bit about this in the beginning of the course. So now we're finally ready to sort of talk about a real poll and think about it both from a design aspect, the way we're doing in the beginning, but also look at the numbers. So what else? In theory, in 19 cases out of 20, overall results based on such samples will differ by no more than 3 percentage points in either direction from what would have been attained by seeking to interview all American adults. What does that mean in English? Yeah, 3% margin of error. And 19 cases out of 20. What does that mean? That's 95% confidence. 19 out of 20 is 0.95. Yeah. So all that's saying is that with my results have 95% confidence and a margin of error plus minus 3 percentage points. And then, in addition to sampling error, the practical difficulties of conducting any survey of public opinion may introduce other sources of error into the poll. Variation in the wording and order of questions, for example, may lead to somewhat different results. In other words, blah, blah, blah. This is hard in the real world. I did the best I could. Stuff happens. So this is what it means to do a professional poll. Now notice that this is what someone who works for the New York Times, let's see, New York Times, CBS News, with the assistance of this guy from Princeton, maybe he's a professor, a professional pollster, I don't know. They probably had a budget of however many $1,000. They conducted the poll over 4 or 5 days, calling people, and then they did the write-up of their method of how they approach this, and they presented their data. Again, pages and pages and pages. Again, some of this data is back data, but some of this is current. All these different questions that they asked. So these are the sorts of things that you should be thinking about if you decide to do the extra credit project. The study. This is an example, and again, I don't mean that you could follow this. Don't follow this, line by line, paragraph by paragraph. But these are the sorts of things that you should be addressing or thinking about. How the sampling was done. What are the possible problems? Actually, that's a really good question. So so there's a paragraph here about the combined results have been weighted. So most, at this point, so in the past, I don't know, maybe say 10 years or so, polling has gotten fairly advanced. So it's no longer just I asked 100 people and 62 said yes. That may have been good enough, say 50 years ago. It's no longer good enough. So many professional polls, or most professional polls at this point, will make those sorts of adjustments. Not everyone does, but most of them do. Again, and of course, those sorts of techniques, that's well beyond the scope of what we're talking about in this class, but that's in there. So how would you know how to do these adjustments and when it's appropriate and which kind of adjustments you should make? That's really the sort of thing that if you're majoring in statistics, that you really study that in a serious way. Absolutely. Yeah. If it's not only is it the sort of thing that has been studied, comparing different regions or whatever, it's the sort of thing that it would be great for you to study or for anyone to study. There's always a need for more data, for more well done studies. That those always help. Let's see. Oh, okay. Now, of course, you guys within the scope of this class, I don't expect you to be able to call 1,000 people on the phone. You guys don't have a week and a half with nothing else to do. You don't have consultants. You don't have a budget of $10,000. So naturally, I don't expect you to be able to carry out a study in this way. However, I do expect you to be able to think about the same issues and address the same issues that are addressed in this discussion that's presented here. So you don't yet have the resources, but you're starting to have the understanding of what's going on. And who knows, if you start doing this right, maybe someday someone will give you a budget of $10,000 to do polls like this. Okay.
you.